There you go.
Yeah. Everyone seeing the screen?
Yep.
Okay. Hi, everyone. We are the Elasticsearchers from the data science track, and our project will be on predicting the CO2 emission rate of your vehicle.
So why should anyone care? Currently, climate change is a global problem in which everyone's awareness of their own environmental impact could really help. So the world transportation sector accounts for 37% of the CO2 emissions from end-use sectors, making a significant part of our awareness needing to be on transportation. We created this product so individuals can have a better understanding of their own car's CO2 emissions in order to be more informed and more careful about what their environmental impact is.
So our story. In the first week, we started off learning the basics of Python and machine learning. We looked at multiple datasets before settling down on the CO2 emissions dataset. Thus, we learned how to train, test, and split our machine learning models. In the second week, we learned and experimented with several different machine learning models in our CO2 emissions dataset. We tried several machine learning model algorithms, finding that the lasso linear regression algorithm delivered the best score out of all these machine learning models. In the third week, we learned HTML, CSS, and Flask basics and got comfortable in writing code for these new programs. Finally, we implemented our findings and everything we learned in the past 3 weeks into one user-friendly website that will make people aware of their vehicle's carbon dioxide emissions.
And now we're going to be talking about our graphs and explaining them. So we're going to start off with one graph, which compares vehicle class and cylinders. So on the x-axis, we have all the vehicle classes, and on the y-axis, we have the cylinders. Since they're box plots, there is no necessarily prominent correlation between the values, but we can notice that two-seaters have the highest range and have an outlier at 16, which is the highest number of cylinders.
So this next graph at the x-axis is the cylinders of the engine, and at the y-axis is the CO2 emissions for the car. And we can see the general trend is that the more cylinders in an engine, the higher the CO2 emissions.
So next is CO2 emissions by engine size, and you can see the x-axis is the engine size in liters, and the y-axis is CO2 emissions. And you can see that generally, the larger the engine size, the higher the CO2 emissions. And then next is a correlation map, which shows the extent to which each of our variables are correlated. And you can see that something that has a really strong negative correlation with CO2 emissions is fuel consumption in miles per gallon, which was useful when building our final product.
This next graph shows a relationship between carbon dioxide emissions and vehicle class. And through the graph, we can see that two-seaters have the highest carbon dioxide emissions. And another thing we noticed was that diesel, which is used in larger vehicles and trucks, still has less carbon dioxide emissions than premium gasoline.
And for the last graph, this is a scatter plot matrix, and it's a scatter plot of all the numerical values in the carbon dioxide dataset.
And now we're going to be talking about the different machine learning models we implemented.
So first is lasso linear regression, which is a regularization technique which uses shrinkage, which is basically when data is shrunk around a central point like the mean. We got a root mean square error of 6.665 and a normalized root mean square error of 0.016, making it our most effective machine learning model and the one that we ended up using for our product.
Next is ridge regression, which is a machine learning model that estimates coefficients in scenarios where the data suffers multicollinearly, which means that the independent variables are highly correlated with one another and the predicted values are far apart from the actual values. The model uses L2 regularization, which is a procedure that prevents excessive fluctuation of the coefficients. And the model also protects the data from overfitting. The root mean square error was 7.660, and the normalized RMSE was 0.0179.
So the next model is the support vector regression, which is based on finding the best line to fit the data points within its margins. And for the SVR, we implemented 3 hyperparameters: the kernel, tolerance, and the cost. After fitting the data with the good search results, we get the RMSE of 19.86 and the NRMSE of 0.047.
So next is XGBoost. It's a machine learning library that uses gradient boosting as its framework for its machine learning model. It works by, instead of taking one big strong learning tree, it takes multiple weak learning trees. So it makes one weak learning tree and it makes a prediction based on the data. Then it makes a second one that finds the error of the previous one and makes a second prediction. And it continues this process through training. With this one, we got an RMSE of 114.230 and a normalized RMSE of 0.268.
The final machine learning algorithm we used was a random forest regressor. And essentially, it's a collection of decision trees. And random forests generally have a higher number of predictive variables and a huge sample size. This is because it captures several inputs at once and thus allows a higher number of observations to be made in the prediction. And with this model, we got a root mean square error of 0.262.
So in conclusion, after trying various machine learning models and determining their normalized root mean square error, we determined that the lasso linear regression model would work best for our data. We then went on to narrow down potential inputs, keeping what the user would know off the top of their head about their car in mind. You can now input details about your own vehicle above in order to use our model and get an estimate of your vehicle's CO2 emissions. We hope that with this information about your own impact, you'll be a more informed consumer when shopping for new vehicles and when using your current one.
So now we're gonna demo our product. If anyone would like to suggest a car, or we have one that we can use.
Feel free to unmute or type in chat.
Kia Rio. I don't know.
Kia Rio? Does it start with K? Kia?
Yeah.
Yeah. And then Rio? This one?
Yeah.
Okay.
It's a subcompact.
Subcompact. Okay. How about the fuel? Okay.
Gasoline.
Gasoline, yeah. Not,
Gasoline. Oh, okay. My bad. Miles per gallon.
probably about 24.
4. Okay.
So our product uses 3 ranges from the US Environmental Protection Agency to determine if the carbon emission is low, mild, or high. The predicted CO2 emission for this car was 279.9 grams per mile. And in this case, the vehicle's carbon emission is not too high, but it's not too low either. This means you have a car that's moderately negative impact on the environment. And some things you can do to help reduce your carbon dioxide emissions in terms of vehicles includes using more public transportation, driving less, and carpooling whenever possible. However, in other cases, when the carbon emission is low, the product will give more lenient solutions to reduce your carbon footprint. And when the carbon emission is high, the product will provide more suggestions for reducing your daily carbon footprint. And yeah, that's our product.
Okay, if you guys don't mind, can I try one more?
Oh, yeah.
Okay, can I do like Toyota Corolla?
Toyota. So T?
Toyota
Okay.
Corolla.
Corolla. This one or?
Yeah, the first one.
Okay.
What do we say? Mid-size, not the mid-size. Okay, let's go with the mid-size. Okay.
Mid-size.
Mhm.
Okay.
Gas.
gasoline, I guess.
Probably
Okay.
28.
28. Okay.
Let's see if I have to replace my car. Okay, that's better. Right, better than Rio, I guess.
Yeah.
Okay, great. Thank you so much.
You're
I love
welcome.
the
Thank
product.
you.
Cool. Anybody want to try theirs?
Yeah. Anyone else want to try?
Okay, Alex,
Yeah.
go ahead.
Mitsubishi
So M. Okay.
Outlander.
Outlander.
I guess it's a small SUV.
Okay.
And then gasoline. And 38.
38. Ooh.
Oh,
Okay.
Hooray!
great.
It's lower than most vehicles.
Oh, okay. There one.
Will,
okay.
you want to try?
Porsche
4. Okay. P.
911, Carrera S.
Uh,
I mean, any of them work.
I'll do GT3.
2-seater. Premium. Should be like 23. 17 for the GT3.
Okay. 17. Oh.
Please don't buy that.
Not too high, but not too
wow.
low.